Section 4.7, Division Properties of Exponents. To divide powers with the same base, you're going to subtract the exponents for like-based items. So if they contain the same base, you'll subtract the exponents and then simplify as necessary. So for the example, 2 to the 6th power over 2 to the 2nd power, you subtract the 6 and the 2, so 6 minus 2, and you get 2 to the 4th. For x to the 4th over x to the 7th, you subtract 4 minus 7, you get negative 3, and then to simplify this, you drop it back underneath. So remember, you're subtracting the exponents. So in example 1, we've got x to the 5th over x squared. They're the same base, so we'll take x 5 minus 2, which in this case gives us x to the 3rd. Is our answer. For 2, we have b to the negative 3rd and b to the 4th. Since we're dividing, we'll subtract the exponents. So negative 3 minus 4, which gives us b to the negative 7th power. We don't want negative exponents, so we put it underneath 1, and we got 1 over b to the 7th power. In question 3, same idea. We have y to the 7/2 power, or we can say y to the 3.5 power over y to the 3rd power. We're going to subtract the exponents. So 3.5 minus 3 gives us y to the 0.5 power, but if we want to be proper, we'll write it as y to the 1/2 power. And that's our answer. So we're just subtracting the exponents of like-based items. So we have m squared n to the 4th and m to the 5th, n to the 3rd. So we've got m squared m to the 4th on top, m to the 5th, and to the 3rd on the bottom. So we'll start with the m's. We're going to take 2 minus 5. So m is 2 minus 5. And then for the n's, we're going to take 4 minus 3. Well, this is going to reduce down to m to the negative 3rd, n to the 1st. We don't want negative exponents, so we'll drop the m underneath, and we get n to the 1st over m to the 3rd. So we take the top exponent and we subtract the bottom one from it. All right, in 5, k to the 6th, j to the 2nd, over k, j to the 7th. So we're going to subtract the exponents on the k's. So we've got k, 6 minus 1. Then we'll subtract the exponents on the j's. So that's j, 2 minus 7. So 6 minus 1 is 5. So we got k to the 5th. 2 minus 7 is j to the negative 5th. We don't want negative exponents, so we move the j. So we've got k to the 5th over j to the 5th. And then question 6, we've got 3 variables this time. We've got x to the 4th, y to the negative 1st, and z to the 8th over x to the 4th, y to the negative 5th, z to the 1st. So we'll start with the x's. So we've got x 4 minus 4. Then we'll go to the y's. We've got y of negative 1 minus a negative 5, so you add the opposite. And then z's, 8 minus 1, so z is 8 minus 1. All right, let's simplify this. 4 minus 4 is 0, x to the 0 power. All right, and then negative 1 plus 5 gives us 4, and then 8 minus 1 gives us 7. Anything to the 0 power is 1, so we can simplify this down to y to the 4th, z to the 7th. And that's our answer. Now we're talking about raising a quotient to a power. So this is just like the previous one where we raised a power to a power. We're going to be distributing the exponent outside the parentheses to the things inside the parentheses, including the denominator and the numerator. So let's look at the example here. 3 over 5, all raised to the 3rd power. Well, the exponent of 3 gets applied to the 3 and the 5, and then we can evaluate from there. Same thing with x over y to the 5th. We apply the exponent of 5 to the x and the y, and then we can do any kind of simplification if we need to from there. So if the fraction is parentheses, make sure you raise all terms to the exponent first. So question 1, z to the 4th over 5, all raised to the 3rd power. So this is going to get applied here and here. So we end up with, well, 4 times 3 is 12, so z to the 12th over 5 to the 3rd. Well, 5 to the 3rd power can be simplified. We'll get z to the 12th over 125. And that's our answer. Question 2, same idea. We're going to apply so we have 3x squared over x to the 5th, all raised to the 4th power. So we're going to apply the 4 to the 3, the x squared, and the x to the 5th. So we've got 3x to the 4th, or 3 to the 4th power, sorry, and then x to the 6th power over x to the 20th power. Remember, we're multiplying the exponents when it's raised to a power like this. So 3 to the 4th we can simplify, and that's going to be 81, and then we're going to subtract the exponents, so 6 minus 20, well, that's going to give us 81x to the negative 14th power. I don't want negative exponents, so I'll drop the x underneath, and I end up with 81 over x to the 14th power. We'll continue to do the same thing in example 3, m to the 4th over n, or 9n to the 7th, all of that squared. So the 2 gets applied to everything inside here. So 4 times 2 is 8, so m to the 8th over 9 squared n to the 14th. Well, 9 squared is 81, so we can simplify that down. The n to the 14th stays, and the m to the 8th stays. So our answer becomes m to the 8th over 81 n to the 14th. When you have an expression like a over b to the negative n power, you need to get rid of the negative exponent before you can simplify. So in order to do this, we're just going to flip the entire fraction over inside the parentheses and change our exponent to a positive. Then we go about the process of distributing or applying the exponent to everything inside and simplifying from there. So example 1, 2x to the 6th over y to the 4th, all raised to the negative 3rd power. I want to get rid of this negative 3 first, so I flip the entire fraction. And then I apply the exponent to everything inside. So exponents get multiplied together, and the 2 just gets the exponent applied to it. So we get y, 4 times 3 is 12, we get 2 to the 3rd, and x, 6 times 3 is 18. We can multiply out the 2 to the 3rd, so our final answer becomes y to the 12th over 8x to the 18th. And that's our answer. Question 2, same idea. We've got 3x cubed over, or 3c cubed over c squared to the all to the negative 4th power. I want to get rid of the negative 4th, so I flip over the entire fraction first. And now I apply the 4 to everything inside. So I'm going to get 2 times 4 is 8, so c to the 8th, over 3 to the 4th, 4 times 3 is 12, so c to the 12th. Now remember, I'm going to subtract the exponents, so that's 3 to the 4th, oops. So that would be 8 minus 12, which would be negative 4, which means, in this case, a negative 4 would go back underneath. So we're going to have 1 over 3 to the 4th is 81, c to the 4th. So that is my simplified answer. Question 3, same idea, a to the 7th over 6a to the 9th, b to the 2nd, all raised to the negative 2nd power. Once again, get rid of the negative by flipping the entire fraction. So now we have a positive 2 outside, and now we're going to apply that to everything inside. So we've got 6 squared, 2 times 9 is 18, so a to the 18th. 3 times 2 is 6, so b to the 6th, over 7 times 2, which is a to the 14th here. And then we just need to simplify. Well, 6 squared is 36, 18 minus 14 is 4, so a to the 4th, and then b to the 6th. And this is your simplified form.